All right, ladies and gentlemen, so welcome to our third mathematics class, third or fourth mathematics class. So in this class, I'm just going to go further and look at another part of the exam, which is the set of numbers. So in today's class, I'll focus on knowing the sets of numbers, what the sets of numbers are, and what some principles that you need to understand. So I'm asking each one of us to pay particular attention, because these are things you are going to find in the final exam. Okay, so I'm going to explain the interval notation. I'm going to explain the interval notation, and this class will have some few notes, so please make sure that you have a pen and a pencil to write down whatever I'll be writing. So when you talk of the interval notation, we're just simply talking about a set which is represented maybe in that form and that form. So there are some sets which are represented in such a form. So when you talk of the interval notation, we're just simply trying to talk about something like that. So yeah, we are joined by my Kagel here. She's now paying attention. She was doing something. So let's start. So we can say let A and B, let A and B be distinct, So when we say distinct, we are just simply talking about different real numbers. So let's say we have A and B to be distinct real numbers with the, okay, with the, let's say A is less than B. So A is less than B. I'm just simply trying to say that A is smaller than B. Then the interval will end with A and B, and then it can be denoted by different way. Okay, so we can say then the interval will end with A and B, and can be denoted or can be shown by the following, or as follows. So there are rules that I'm going to outline as I try to explain this. There are rules that I'm going to outline, and please make sure that you are able to follow up. Please follow up. So I'll start with the first one, which will be my number one. So in my number one, I'm going to say open brackets A comma B. Okay, this is the interval notation. So in such an interval notation, this simply means that, let's say X is a member of real numbers. X is a member of real numbers such that this X is between A and B. This X is between A and B. And knowing that X is just a real number. So when you say a real number, you're just simply talking about any number in the universe. Now, in terms of this, since these brackets are like this, okay, since these brackets are like that, so this simply means that this expression, this interval, it is what? It is an open. Okay, so we can say let A comma B with those brackets. So this bracket, they simply mean open. Okay, be equal to that, and it is what? And it is open. So when you see any bracket which is expressed like that or that in mathematics on set, it simply means that such is open. Okay, so this is just an open interval. I think that is clear. So this is the first thing that each one is supposed to know. This is the first thing which each one of us is supposed to know when it comes to interval notation. First thing that each one of us is supposed to know when it comes to interval notation. Okay, so in such a case, we're just saying from A to B, from A to B. So if you look at this, okay, if you look at this, you need to understand that what does this simply mean? Okay, what does this simply mean? Okay, so let me translate the meaning of what has been explained here, or what has been what you need to understand there. Okay, so I'm going to write meaning there. Okay, so in this case, the meaning for such an expression, whereby you have A, comma B brackets. So this means that the set has numbers between, okay, has numbers between A and B, has numbers between A and B. That's the first thing you need to understand. Has numbers between A and what? And B. Okay, the other thing, because it is an open bracket, look, this is an open bracket, like I've already explained there. This simply means that A is not part of the set. A is not part of the set, is not part of the set. Guys, these are exam concept. You need to know them. Once you know this, then be assured of passing quiz 1. Nishwamenya ka question 2 of quiz 1. Once you know this. So A is not part of the set. Okay, A is not part of the set. And also this also means that B is not part of the set. B is not part of the set. So B is not part of the set, part of the set. Okay, so if you have such an expression, let me give numbers, maybe numbers you guys can relate. So when you have numbers, let's say you have a number like -1, comma, let's say 5, right? So in short, here we are talking about the sets here. It is all the set, all the members, okay, all the members between -1 and 5, but -1 and 5 are not part of the what? Of the set, are not part of the set. Okay, now there is something that we have shown here. There is something which we have shown here. Okay, so what we have shown here is that -1 is not part of the set, 5 is not part of the set. Okay, but all the numbers between -1 and 5, these numbers can be fractions which are rational, these numbers can be decimals, these numbers can be integers, these numbers can be any number which we can simply talk about. Okay, now when you have this information in your mind, you should be able to change this information from the interval notation. Now you have to change it into a what? A number line. So let me quickly show you on how you can show it on a number line. Okay, so if you want to show it on a number line, this is how you can do it. If you want to show it on a number line, so you have to show a number line like that, okay, that arrow. Remember, you have what? You have x to be a member of all real numbers. So this side you're going to put negative infinity, that side you're going to put positive infinity. So if the universal set is real numbers, then your set is from negative infinity to positive infinity. Then to show this work on a number line, this is how you can simply show it. So you're going to draw a bar on top, and this bar you put an A down. Then you can also put a bar on top, and this bar you put a what? A B down. Now there is something that is very important to indicate, and this is the circle on top. Remember, I'm trying to represent this on a number line. So then for you to know what kind of circle you need to put on top, you need to look at the brackets there. So in such a case, you're going to just do what? You're just going to put an open circle without shade, and also another open circle, because this is open and that is open. So an open circle you don't shade, an open circle you don't shade, then you mingle them like that. This color line has to be there, because these guys are what? These guys are connected. We are considering the members which are on this particular part. So this is how you can represent this set. Interval notation. So when doing interval notation, you should be able to change from this interval notation to the number line, and also you should be able to change the interval notation to the set builder notation, and vice versa. Ladies and gentlemen, is there any question on this particular point? Is there any question on this particular point? No question? Florence, what's your question?
So I wanted to ask, is this the first part of the mathematics for today? Because I had to go to this, so this is when I...
Yes, it's the first part. This is the first part.
What is question number one saying? I'm not able to see properly. That what?
These are notes. Let A and B be distinct real numbers. You can see now.
If you don't mind, you can just leave the whole sentence.
Ulimpofu. Let A and B be distinct real numbers with A is less than B. The interval will end with A and B. Can be denoted as follows. Now you have understood.
Thank you very much.
Mukashitama girasi. Kamwala yajichipa. Okay, let's move on. We can also come up with 2. We can also come up with 2. And these 2, let's say you have that particular one, A, comma B, A, comma B. And then these brackets are like that. I think let me write them properly to avoid people not writing them properly. So let's say you have this particular interval. So in this particular interval just simply means that open bracket, you write open bracket x such that x is a member of real numbers, and then you can say such that x is between A and B, x is between A and B, okay? But in this case, since these brackets are the one which have been used, then that will be less than or equal to and then that one less than or equal to. So in such a case, since these brackets, okay, these brackets are the one which have been used, there down there you're going to put what? The less than and equal to. You can look at the difference between the two. You can look at the difference between the two. So the first one, you find that we did not put the equal to there. The first one we did not put the equal to, but this one we have put the equal to. So after you do that, you need to understand one thing. You need to understand that this is the what? Is a closed interval. This is the what? A closed interval. So this is a closed interval. So if you look at that, these are just the closed what? Closed brackets. So these guys are known as what? Closed brackets. So please take note of that. So these are closed brackets from A to B, from A to B. So these are closed brackets from A to B. So if you were to sketch this on a number line, this is how it will look like. So you're going to put that, and then remember we are talking about real numbers. So this will be from negative infinity to what? To positive infinity. From negative infinity to positive infinity. And then on top there, you're going to put A, then bar again, you put B. So since these are closed brackets, okay, since these are closed brackets, please guys, let's take these things seriously, and let's take them with much care. This is where our life depends on. So these are closed brackets. So when you do closed bracket, when showing a number line, you're going to shade. When showing a number line, you're going to shade like that. Okay, you're going to shade like that, and then this is what? This is how you're going to sketch it like that. You're going to shade. What we are simply focusing on is just that. Okay, now what is the meaning of this? What is the meaning? In short, the interpretation. So this is very important. Let's look at what it simply means. So this simply means, number one, you can talk about all members between A and B, all members between A and B, between A and B. And then two, you can say A is part of the set. A is part of the set. A is part of the set. And then also B is part of the set. So B is part of the set. B is part of the set. So that's what you need to know about that. So this is how easily the work is. Nothing more, nothing hard. Okay, so at this particular point, I can allow, if there is someone with a question, you can ask, so that we move at the same pace. Any question, ladies and gentlemen? Any question?
So B and A only becomes part of the set when they are in a closed set, yeah, or in a closed bracket. What?
Exactly. When A is in the closed bracket, it is part of the set. When B is in the closed bracket, it is part of the set. That's why we have even used the shaded circles. But if it is like in the case of the previous one, they are not part of the what? Of the set. Is that okay now?
Yes, it is.
Okay, Twalumba. Let's move on and look at the next one. So this is my third one.
Sorry to interrupt you. On the part for the closed brackets, I don't know if you said closed interval.
Yes.
I think there's one of the videos that I watched on YouTube where you said I don't know if you call them blocked brackets. So if you use blocked brackets or closed brackets, is it wrong? Or maybe blocked brackets is another set of brackets?
It is correct. Blocked bracket and closed bracket, they are one and the same. So let me also explain on the difference between the classes and also the videos on YouTube. Most of the time there are some content on YouTube which I leave out. I don't give everything, but when you talk of the class, I use the simple ways. So I leave some certain things. Let's say I say blocked bracket. You on your side, it will be very hard to remember a blocked bracket. But here in class I say closed bracket and I also open brackets. You'll be able to remember that there is open and closed. When it's open, the circle is not shaded. That's why it's open. It's more like the door. When it's open, the door is open, so it's not shaded. But when it is closed, then it's going to be shaded. In short, the door will be closed. Yeah. So, but on YouTube, I'll say open and block because I know someone cannot remember the two. Yeah, because they are not opposite. Okay, we move. The third one. The third one, I think this one I did not explain it on YouTube. So this one is, let's say A and B like that. Okay, A and B like that. So this is partially open and this one is closed. So this one is open, this one is closed. So this one can be written as follows: X is a member of real numbers. X is the member of real numbers such that X is between A, such that X is between A and B, such that X is between A and B. But one thing we need to understand is that A is open, okay? A is open, but B is closed, meaning where there is A, you're not going to put an equal to. But where there is B, you are going to put an equal to like that. So this is how your work is supposed to be. So this is set builder notation. This is the other one. But most exam question, you need to change from set builder notation, then you take it to that, and then you use the number line. So this one is a half open and the half closed the interval. So this one, this is half open and the half close the interval, half close the interval. Okay, closed interval, because we are having a part of we are having the part which is open and the part which is closed. So those are the two things that you need to consider. So when using a number line, this is how you're going to show it. This is how you're going to show it. You're going to have that. Since it's real numbers, so you're going to say negative infinity, and then that side positive infinity, and then you can put block A and then block B. Then the next thing that you need to look at are the shading. So on top, since this is open, you are going to do what? You are not going to shade it, so it's just going to be like that. And then the other one, which is closed, you are going to shade it like that. So when you shade, and lastly, the only thing remaining is for you to connect them like that, and then you can just do that. So what does this mean? What does this simply mean? Okay, so I'm going to say meaning. Okay, so when I say the meaning here, you're going to have the same thing. The first thing is numbers between A and B, numbers between A and B are members of the sets, are members of the set. Then B, you can say A is not part of the set. A is not part of the set. A is not part of the set. And then B is part of the set. B is part of the set. B is part of the set. So this is what you can interpret from that. Okay. Is that correct? Is that okay with you or not? Any question before I move on? Okay. Florence has a question. Florence, what's your question?
Alright, I wanted to ask now why numbers between A and B part of the members of the set. I don't know if it's members of the set.
It is
A
interval.
part of the set.
It is interval. The word interval means between. So when a set is represented like that, it simply means that anything between A and B is part of the set. This is not listing but interval. Then why is A not part of the set? Because the bracket used there, it is an open bracket. Why is B part of the set? Because the brackets written there, it is a closed bracket. Is that clear?
Yes, sir. Thank you very much.
You're welcome. So I know math is all about much of solving. So let's quickly look at an example. Okay. Am I out? Guys, are you able to get me or I'm out of the meeting?
You are very much audible, sir.
Oh, I thought I've been knocked out. Okay, so let's quickly look at the example. Please, this example is very important, and the good part is that there are some few questions I've solved on YouTube, so you guys will also be able to go there. So let's quickly move on. Given the set, so given the set, so I'm taking this from the exam paper. So given the sets, A is equal to open brackets -2, 6 block bracket or close bracket, and then and B be equal to, let's say you have block brackets -5, 3, and then we have block brackets, then we have C which is equal to block brackets -1, 8, and then you have open brackets, and let's say you have X be equal to, let's say open brackets -10, 10 close brackets, of which we know X is the universal set. X is the universal set. X is the universal set, and then you can say find the following sets. Find the following sets. Okay, find the following sets. Okay, so let's quickly look at this particular example and see what we can do. Let's quickly look at this particular example and see what we can do. So the first one is A So for A, we can say, let's say we have A complement. They have come. Those things we did last time, they are here. They are back for us. Then B, let's say B, we have x minus A, x minus A, and then you can say C, which can be open brackets A intersection C complement, A intersection C complement, and then D can be B minus A intersection E C. Okay, so we have this question. So let's quickly look at this question and let's see how best you can easily solve it without having any challenges. Okay, we can move. We can start with A. So for A, it is A complement, okay? And you need to note that A is simply equal to open brackets -2,6 close brackets. Now, let me emphasize on this. If a question is like this, do not think about any method apart from the number line. So whether it has come as an interval, if it is an interval, like let's say this guy here was represented as x is the member of x such that x is between -2 and 6, -2 and 6, and then you know that since it's block, you put that, and then you say, so since this is closed, that's why I've put a block. So in case this set was represented in that way, get this, change it to that, then you go the way I'm going to go. So whether it is in whatever form, use a number line. Don't just look and say, oh, there are many answers. No, use the number line. So you're going to draw your number line like this. Now, there is something that I had to hide from the channel, which is how to express a set. Let's say the universal set is not the real numbers. Remember, the universal set we had is x is equal to open -10, what, 10, like that. So how do you represent this work? So the way you can represent this work is by simply putting a 10 at the far end there. You put a 10, a -10, because that's the universal set, and also another 10 there. If it is infinity, we had to put the R. Then after you do that, you get a what? You get an open bracket because it is open, and that one also an open bracket. So what I have drawn here is the universal set, but I have not responded to the what? To the question. So now, after I do this, the next thing that I need to put on this, it is the demarcation between negatives and positive, and that is what? 0. So after I put a 0, then I go and get what? The set I have. So the set I have in this case, it is -2 and 6. So I'm going to write a bar -2. Then I'm going to put a bar a 6. Then I'm going to read what bracket is on 2. It is open, so I'm going to use that circle there. What bracket is there? It is what? It is closed or blocked, I'm going to use a shaded circle like that. Then I'll link them like that. After I do that, the next thing that I'm going to do is that I'm now going to label this guy as what? As set A. This is the set A. Now, I have found set A on this number line, but what am I looking for? I'm looking for set A complement. In short, members that are not in set A. So I'm going to do this. Pay attention on this one. Pay attention on this one. I'm going to put on top there, I'll put a bar. Okay? Then, because negative 2 is not in A, because negative 2 is not in A, I'm repeating that. Because negative 2 is not in A, that means that the complement as negative 2. As a result, I'm going to shade it like that. I'm repeating that. Because negative 2 is not in A, that means that negative 2 is in the complement. So I'm going to go up and shade it and also bring this one on top. Because this part is not occupied by A, it's going to remain the way it is. And then connect them like that. And this part, which is in blue, is simply what? A complement. I'll go to the other side again. Because 6 is not in A. Because 6 is not in, because 6 is in A, sorry. Because 6 is in A, that means that 6 is not in the complement. And then this side, it will be maintained the same way it is. And then I'm going to connect them like that. This part is also set A complement. Therefore, my answer can be represented on a number line again to just show what? The A complement. Because some question they'll say, and to sketch on a number line. So you need to make sure that you know how to do it. So my negative 10 will be on top like that. It will be open the way it is. Negative 10. Okay. Remember there, I'll also remove the brackets and then I'll put 10. Then it will go on top and then it goes like that. Then after that, what you need to do is you're going to write your negative 2. You go on top. You're going to write your 6. You go on top. You write what was written on top for the complement, which is like that. You connect them. Then again, this one is shaded like that. Then you do what? You connect them like that. If you want, you can even do that. If you want, then you also do that. So this is your A complement and then also A complement. But remember, these are two sets. So in interval notation now, you need to work in interval notation. So this will be A complement is simply equal to A complement is simply equal to, you're going to use this one as open bracket, negative 10, comma, negative 2, then this is shaded, close brackets, union, okay, open bracket, 6, comma, 10, open bracket. You're done. Any question? Any question, ladies and gentlemen? Yes, I can see Benzo has a question. What's your question, Benzo?
First of all, where how did Nick do have a shaded dot when you said it was exempted, and on the part of you saying negative 2 is part of the complement as well as 6.
Yeah,
I didn't get your point.
your question is the
Six
same.
being part of the complement.
Okay, you're asking the same thing. Where you're behind is how did -2 become part of a complement? How did -2 become part of a complement? Is that -2 according to A, -2 is not part of A. According to A interval here, -2 is not part of A. As a result, when looking for members which are not in A, -2 is part of A, is part of -A complement. So -2 here is not part of A. As a result, -2 is part of a complement. -2 is not a member of A. Therefore, -2 is part of a complement. Is that okay now? That's why it is block. 6 is part of A. 6 is part of A. As a result, 6 is not part of a complement. Is that okay, Benzo?
You're saying 6 is not part of a complement, but as we are uniting the sets for a complement, 6 is there and it is 6,10.
The brackets which is next to 6, what does it mean? What does this bracket mean?
It's an open bracket.
What does it mean? What you are saying is the name.
Oh, it means it's not part of. Oh, okay. I get now.
Thank you. Thank you. Now I understand why Jesus was responding with questions. Wow. Wow. I've learned a lesson. I'm going to give B as an assignment. B, this one. It's an assignment. Assignment. Yes, Taonga, what's the question?
My question was on the universal set. It's open bracket -10, comma 10.
Yeah.
Does it have an open bracket or it's closed?
It's open.
It's open.
Yes, I did not include it. It's open. The picture is showing. Okay, let's move on. So B is an assignment. Then I'm going to do C. D will be an assignment. For you to solve D, you need to go and watch the tutorial on YouTube on the same thing. There is a video I made about that. So I'll send the links after the class. And then this class will also be sent to you. But this class will be sent privately, meaning it won't be for the public. Okay. So I'll look at C, which is open bracket, A intersection C complement, A intersection C complement. So in this case, my advice is, since you have such a complement outside, do not multiply it throughout, because if you multiply it throughout, it's going to give you complement union C complement, A complement union C complement. So you know, then that simply means that you are making an added step to it, so you might end up losing time. So we are going to sketch the universal set, which is -10 open, and then we can also sketch 10 there open. This is the universal set. Then on this diagram, since we are looking for A intersection C, we can simply analyze A. So A is simply equal to open bracket -2 comma 6 close bracket, and then C is simply equal to block bracket or close bracket -1 comma 8 and then open bracket. So you're going to show these two sets on one single number line. You're going to show this set on one single number line. So you demarcate a 0 there, then you're going to put -2 and then also 6 there. On top, you know that is closed, so you're going to say like that, and then that is open, you're going to put like that. Then you do that. Then the next thing you're going to do is you're going to show set C. Set C is from -1, okay, to 8, -1 to 8, like that. And then this is up there, and this is part of the set, and then that one is not part of the set, like that. Okay, so this is set C. So this is simply set C. So if you look at set C and set A, you can now look for the intersection between these two. You can look for the intersection between these two sets. So the intersection is simply this region. So this is the intersection set. So if you look at A intersection C, okay, A intersection C, I've just picked what's inside. It's simply equal to this region, and this can be interpreted as -1 is part of A and it's also part of C. So you're going to use block brackets -1 and then comma. You look at 6 is part of A and it also part of C. So you're going to put 6 and then block bracket. So when you find A intersection C, you can now look for A intersection C complement by simply using the words the number line once again. So it's going to be like that, and then there it will be -10, there it will be +10, like that, of which we know this is not part of the set and that is also not part of the set. So after you do that, you're going to put A intersection C on the number line. You demarcate 0 there, so you have -1 there, you have also 6 there, of which you know -1 is part of A intersection C, and also 6 is also part of A intersection C. Then when you connect these guys, this is what you're going to have, which is A intersection C. Now we are looking for A intersection C complement. That means that we are now going to go the opposite way. So this means that there you're going to go up, and also that one you're also going to go up. That one will go up, that one will also go up. If you observe, -1 is part of A intersection C, so it's not part of A intersection C complement. So it's going to be open, and there it's going to be open. Then you connect them like that. What we said here is the same thing that can be said about C. So this one will be open, and then that one will also be open. Then you connect them like that. So this is the set we are looking for, like that. So that means that A open bracket intersection C complement is simply equal to this guy is open -10 comma -1 open union, then you say open 6 comma 10 open. So this is your final answer. Easy. Any questions, ladies and gentlemen? Any question? Any question? I can see Lukondo. Lukondo, you have a question? What's your question? Lukondo, what's your question?
For this solution which we have, isn't negative 10 and positive 10 supposed to be part of the set?
No, they are not supposed to be part of the set because they are not part of the universal set. The universal set is Z. The universal set is X is equal to open negative 10, comma 10. That's the universal set. Right. So this thing can be represented on the number line. That part can also be represented on the number line. So you can just simply say that. Then you say negative 10. Then it is open. Then you have positive 10, which is also open. Then one thing that you need to understand is that this time around we are moving from negative 1 and 6, and then both are open. That one is also open. You do that, and then you shade like that. If you want, you can shade like that, or if you want, you can leave it like that. So this is still A intersection C complement, and that one is also A intersection C complement. So this is the final answer. Any question, ladies and gentlemen? Yes.
I said like when answering you should not multiply complement.
We should.
Multiply it to wrong the process. I don't know if we can try because I feel like for A we want a complement.
Yeah. You now look for C complement.
Yeah, so now look for C complement. That was
You can do that, but the thing is, it's not always that A will be related to that.
okay.
Yeah.
So,
Okay.
So in this case of intervals, we cannot apply any of the laws of algebra, or they can be applied somewhere.
They can be applied in case you want to simplify. That's where the game of the test, quiz, and exam are. So when we try to work out on that, for during the revisions, we'll play some cards on that. Is that okay? Is it okay?
Yes, but
So let's look at example 2. Let R be the universal set. So when you say R is the universal set, then that simply means that real numbers. And then you can say, D, I've written that assignment.
okay. I thought it's only B.
Oh, mukose daddy, koseni daddy. Comma, B is equal to open negative 1, comma 5, blocked, and then and C be equal to block 0, comma 4.